This is the last session for VXLAN. We are going to talk about the control plane protocols that get along with the VXLAN. We are going to include multicast and how multicast is known as flood and learn when it works with VXLAN. And we are going to compare EVPN with LISP. Multicast is actually the first control plane protocol that was defined to work with VXLAN. It is described in RFC 7348. It is quite good at simulating bomb traffic within the layer 3 network. This behavior is known as flood and learn, and it is quite good at, for instance, simulating ARP requests over the layer 3 network. Okay, let's describe how multicast actually works as a control plane, helping VXLAN to figure out what are the destination VTEPs that it needs in order to create its tunnels. Let's illustrate this with an example. Let's say that this host here wants to communicate with this host over there. Remember that when we use Ethernet and IP, we usually use an ARP table. The ARP table is going to tell us what is the MAC address that corresponds to a certain destination IP. So actually this host A is going to send an ARP request asking for the destination MAC address for this destination host. So it is going to send a frame. It is a layer 2 frame that is going to have a destination MAC of a broadcast. Remember that this is the destination broadcast for layer 2. Now, when this frame arrives to VTEP X is going to encapsulate this ARP request frame. So remember how the encapsulation works. It is going to encapsulate the Ethernet frame that it is actually a broadcast, but we are going to add an IP header, a UDP header, and a VXLAN header. Now, the way that it is going to build this encapsulation depends on your configuration. So if you mapped this VLAN to some VNID, let's say 10, 10, 10, and then this VNID was mapped to a multicast group, let's say 239.10.10.10, then this VTEP is going to use this information in order to encapsulate this broadcast. It is going to use the destination IP within this IP header in order to build a multicast packet. So it is going to set the destination IP as 239.10.10.10, and the VXLAN ID that is going to inject into this VXLAN header will be 10, 10, 10. So this packet is actually a multicast packet. So it is going to travel through all the layer 3 network. It is going to arrive to all VTEPs that have this configuration. So eventually it is going to reach the actual VTEP that has this device connected. So the first thing that this VTEP is going to do is it's going to actually forward this frame to the destination host. So the process from the standpoint of the host V is just natural. It doesn't know that there is VXLAN in the middle. It just believes that this is a regular, normal layer 2 network. And the other thing that this VTEP Y is going to do is going to respond to VTEP X. So it is going to let VTEP X that VTEP Y is actually the destination VTEP in order to reach this particular host. So this is how multicast plays its role as a control plane. It is actually helping VTEPs to know what are the destination VTEPs in order to build tunnel. So any further frames arriving from host A are going to be successfully tunneled to the adequate destination VTEP. Hope that makes any sense. The configuration is quite straightforward. We are showing the configuration for Nexus and iOS XE. We are going to first configure PIM sparse mode with this device as the rendezvous point. Then we are going to map a particular VLAN to a VNID. This becomes a layer 2 VNID. And then we are going to map this VNID to a multicast group. This is how we enable a multicast as the control plane for VXLAN. Now, although multicast was the first control plane defined for VXLAN, and it is good to simulate bump traffic, for instance, to simulate ARP requests, we can become overwhelmed by the amount of multicast within the core. So we can replace it with something that is known as ingress replication, where we are going to use many unicasts in order to replace each multicast. Now let's talk about the other control plane protocols that exist out there that you can use as a companion for VXLAN. We have multi-protocol BGP with EVPN, and we have LISP. You can choose to combine them with multicast if you want. So you can let multicast there to handle bump traffic if you want to, but you can also enable ingress replication for these two options. If you do so, you could get rid of multicast if you want. So let's compare them through several features. The first feature that we are going to use to compare them is whether they are standard or not. In the case of multi-protocol BGP with EVPN, it is a multi-vendor standard, whereas LISP for Fabric solution is actually a Cisco modified version for LISP. So if you want to run LISP for your Fabric, you will need Cisco devices only. Now, regarding support for VRFs, multi-protocol BGP with EVPN supports VRF natively, because multi-protocol BGP can identify VRFs using route targets. Route targets travel through advertisements using extended communities. LISP supports natively VRFs also through LISP instances. Now, regarding support for underlay protocols, multi-protocol BGP with EVPN supports any routing protocol, whereas the Cisco Fabric solution only supports ISIS. Now, regarding the mechanism, multi-protocol BGP with EVPN will advertise several types of routes that we call route types. We have route type 2 in order to do layer 2 forwarding, route type 3 in order to do bump traffic, and route type 5 in order to do layer 3 forwarding. Now, LISP uses the traditional messages. For the Fabric, we are going to map layer 3 VNIDs that exist within VLAN to LISP instances. And we are going to handle endpoints ID that can be IP addresses or MAC addresses. Now, if you enable ingress replication for multi-protocol BGP with EVPN, you will be using route type 3 that are known as IMET routes. And for LISP, there is a feature that is known as hidden replication, which is performed by ITRs. That's it.